Hello everyone, in this video we're going to talk about how we can graph some natural base functions. So if you notice here at the top of the screen, we have the natural base exponential function y equals a times e to the rx power. So if you want to review what is e, you can check out the video in the top right hand corner in the cards right now. It's a video that I did earlier just talking about what is e, what is the constant that it's approximately equal to. And so that'll give you a little bit of context into what we're talking about in this video. So with the natural base exponential function, we could have exponential growth, which we see on the left side of the screen in white, or we could have exponential decay, which we see on the right side of the screen in pink. So if you notice the difference, it is just whether a is greater than 0 or if, or excuse me, not a, it is if r is greater than 0 or if r is less than 0, okay? So for exponential growth, we have our basic function here, y equals e to the x power. So notice that we're going to have the point 0, 1 because anything to the 0 power results in an answer of 1. So if we plug in 0 for x, we do get y is equal to 1. So that point is on, notice on both of these graphs here. And so when y is equal to 1, we would get 1, 2.718 because that is what e is approximately equal to. And so those are 2 points that would be on this graph. And so in just a minute, we're going to look at some examples. We're going to identify would this be exponential growth or would it be exponential decay? And then we can use our graphing calculator. We can graph the function and use the table feature in our calculator, or you could just make a table of values yourself, which is what we're going to do in this video. Use our calculator just to plug in the numbers and figure out what our values are. So now on the right side of the screen, we see exponential decay. And that is when r is less than 0. So notice here that our exponent becomes negative x. So we have y is equal to e to the negative x power. But once again, if x were to be 0, we would have e to the 0 power, which would result in 1. So you notice we do have 0, 1 on both of our graphs here. Okay, and so another key point on our exponential decay basic function here would be 1, 0.368. And once again, that would just be like if we plugged in 1 for x and we evaluated on our calculator e to the negative first power, that's the approximate decimal that we would get. Okay, so let's take a look at a couple examples here. We're obviously going to graph these, but then we want to see if we can tell from the equation if it's going to be growth or decay. So for example number 1, we have f of x is equal to 2.5 times e to the x. So if we notice that we have x right here, and so our value for r would just be 1, because if we go back to our original equation, we had y is equal to a times e to the rx power. And so if r is not there, that just means we have a value of 1. So that means r is positive, so this is going to be an exponential growth example. All right, so now what we can do, we know we're going to have the point 0, 1 on our graph, so we can go ahead and plot that. Because when I plug in 0 for x, like we mentioned a second ago, we're going to have e to the 0 power would be 1. And actually here, since we do have a 2.5 on the outside, we're going to multiply 1 by 2.5. So this would actually be 0, 2.5, because we're multiplying e to the 0, 1, by 2.5. Okay, so we can put our point here at 2.5. Okay, all right, so now we're just going to use our calculator. And we're going to plug in the rest of these values that we see here. Okay, so I'm going to use x value of negative 3. So let's do 2.5 and then e to the negative third. And we get 0.124. So 0.124. So negative 3, 0.124, we'll put it about right there. And now we'll do 2.5 times e to the negative first, and that's 0.920, so 0.920, so negative 1 and almost at 1. And then we'll do 2.5 times e to the first power, and that gives us about 6.80, so 6.80. So 1 and 6.8, so almost 7, so about right there. So if you notice, we do have our exponential growth curve happening here. So let's see if we can draw our curve through these points here. Okay, not too bad. All right, so we suspected it to be exponential growth from the way the equation looked, and our graph reflects that. So we're good for number 1. All right, number 2, notice we have y equals e to the negative 0.2x. So that negative in there, that's less than 1. So that's telling me this is going to be exponential decay. All right, so now once again, let's plug in some values that we can use for x, use our calculator and plot our graph. Now we don't have an a value here, or we do, it's just 1. So we are gonna have when x is 0, that's gonna be e to the 0, so this will be 0, 1, which is what I tried to do on the last one, but we did have a value of a that was other than 1, so that's why it was 0, 2.5 for number 1. Now we're going to take our calculator and we're just going to type in e to the negative 0.2, so negative 0.2, and then we're going to multiply that by negative 6. So basically in my calculator I am doing e to the negative 0.2, and then inside or next to the exponent, right, still the small number at the top, I'm putting negative 6 in parentheses, and I hit enter, and I get 3.32. So 3.32 for negative 6, so that would be about right here. So negative 6 and 3.32. All right, and now for 3, so let's do e to the negative 0.2, and then multiply that exponent by 3, and we get 0.549, 0.549. So 3, 0.5, right, so down there. Okay, all right, and now for number 6, we're going to do e to the negative 0.2, and then we're going to multiply that by 6, and we get 0.301, so 0.301, and that's going to be really, really small down here at the bottom, okay? All right, so now what we can do, right, we have negative 6, 3 there. We're going to draw our curve here, so we see we're coming down and through our points here, and now we can see we have our exponential decay, right? So for number 1, we saw that our r value was positive, so we had exponential growth. For number 2, our r value was negative, so we had exponential decay, and that is how we can graph some natural base functions.